Welcome to this video about multi-scale setups using the FastFlood web platform. So today we're going to look at how you can simulate flood processes rapidly for large regions, but still provide detail for areas where you require it. And we're going to do this by setting up hybrid simulation skills. So we have one simulation at coarse resolution that focuses on the larger hydrological routing, and we have a second simulation domain, or many more, that focus on higher detail for local areas, perhaps urban areas or critical points in the channel routing. Now, let's have a look at the website. So I have the website open, and I'm going to go ahead and first have a look at an area that is in the south of the Netherlands and experienced some flooding a couple of years ago. So right here we have the catchment of the Geul, and I'm going to go ahead and select that catchment, make sure I get the entire area. Now this is quite a sizable area, and I don't want to model this in the highest resolution that's available. So what I'm going to do is I'm going to say, maybe let's model this at 150 meter resolution. Now I can choose alternative datasets if I'm using the FastFlood Pro subscription, but for now let's stick with the SRTM data. Okay, so I have the data downloaded. We can go ahead and run a simple simulation. For now, I'm just going to set the precipitation for what it approximately was during that event, and I'm going to go ahead and press simulate. Now at this scale you get somewhat simplified results, and they lack some detail, but the model's output is there instantly, and you can rapidly make changes. Now what we can do with FastFlood is make a multi-scale setup. So let's say I'm interested in the city of Valkenburg right here. Now there's a couple things I notice. First of all, the actual floodwaters are not following the exact route of the river. Now there's a built-in tool in FastFlood to help you solve this. If we go to the channel options, we can specify first that we want the discharge routing to happen over single paths. So monodirectional channels. Then we're going to output the channel shapes, and in that way we can later edit it. And just to have some additional output, we're also going to activate output discharge estimates. So let's run the model again. There we go. So what we see now is the channel network that is estimated by FastFlood, and we can now also visualize the discharge estimates. And using the shift button, we can actually also see the values. So these are the discharges that are flowing through this region. Now at the moment, these are quite high values. We can increase the realism here quite a bit by also including infiltration. So I'm going to go ahead and automatically download some infiltration data. Run the model again, and that already lowered things significantly. Okay, what we can do next is say, right in this location, after the city, we see that the core scale elevation model doesn't work so well for FastFlood and how it estimates the channel network. But we can go ahead and edit this. And right there we get access to the editing, so we can go ahead and change the path of the river here and make sure that in the areas where we're interested, it follows the actual shape of the river. We can also add points here. Now it's also an option to upload your own shapefile if you already have a dataset of the river paths defined beforehand. And that way you can use data that has the quality that you want. Now I'm going to go ahead and save this. If I want to use this in my follow-up simulation, I can go ahead and under the channel options, make sure that I stop outputting the channel shape, but use the edited channel routes. Now let's simulate again, and we immediately see the changes that are the result of this, right? So now the discharge is routed along the channel network that we defined. Okay, so we have this coarse scale simulation working, but now we want a bit more detail. Now FastFlood comes with a built-in tool for upscaling your results to a higher resolution. We can do that by looking at the menu at the top left and clicking the plus button there. This will give us a second model area. If we press this, we get a clear area again, and what we can do based off this is, say, define a new model domain. So I'm going to automatically download elevation for the inner part of Valkenburg, and I'm using the higher resolution Dutch national elevation model here, which is 5 meter resolution. There we go. Now, what we can do as a result of this is say, well, here I'm not going to model the floods based off rainfall and hydrology and flow, but instead I'm going to use the upscaling tool. And I'm going to use the input from our first model area and do the upscaling here in our second model area. So when I go ahead and press simulate, we see immediately that our results from the low resolution simulation are immediately transferred and, using a physically based method, given a reinterpretation in this higher resolution landscape. Now, this elevation model at 5 meter resolution does include buildings, so you see that indeed the buildings themselves are obstacles for flow, but surrounding these you see that the water inundates the central part of the city, as it did during the event. Thank you for watching this video. I hope you find it useful, and I also hope you find the fast-to-work rapid flood simulation tool useful. If you have any questions about the platform or about the methodology, please reach out and contact us for more information. Thank you very much.